together, see what I'm dreaming. When I find the pieces, when I find the pieces, when I find the pieces, who knows I haven't looked, but I feel it. Put the puzzle back together, see what I'm dreaming. When I find the pieces, when I find the pieces.
Well, welcome back, Algebra 1 students. So we're going to be looking at piecewise functions in this lesson. So looking for pieces, we're looking at functions are now going to be in pieces, and we're going to have to write a couple functions in pieces. So we're evaluating piecewise functions, we're graphing them, we're writing them, and we're going to look at some things called step functions, which are very similar to piecewise functions. So we have a cartoon to get started here. Little Garfield cartoon, him and John have a conversation. I think I'm thinking of a number between 1 and 10, he says to Garfield. Garfield looks at him, pats his head. Good for you. John can think of a number between 1 and 10. Wow, that's amazing. All right, let's move on to our piecewise function. Okay, so this core concept is on page 128 of your notes, and you can see it shows you the piecewise function. Just go ahead and highlight the vocabulary here. That's a function defined by two or more equations. And so we're going to have these equations be either just like linear equations, or they could be constant functions as well, just going straight across. But as you can see here, we have two equations, two linear equations like y equals mx plus b, and with each one it has a particular domain assigned to it. It says the function here, f of x, is x minus 2 if x is less than or equal to 0. So what that means is the expression x minus 2 represents the value of x when x is less than or equal to 0. And that's this function here. So you can see there's the less than or equal to with the solid hole, and it's on the left. So when it's less than the 0, it's on this side. And the function is 2x plus 1 when x is greater than 0. So it's got an open hole here, and then it just uses that function then from that point going up for greater than 0. So kind of think of the graph as you go along from the x-axis. We're looking at just the domain. So remember, the domain does mean where is this graph on the x-axis. And so you have for each equation, you're going to have a separate domain for where that's located. So you can see there's two pieces on this one. Piecewise functions could have more than two pieces. Most of them are going to have two pieces that we're going to see. Okay, so on the top of page 129, we see our extra practice. We're going to look at 1 through 9. Here we are going to evaluate these piecewise functions. So we're given two functions, f of x and a g of x, and they're piecewise because they have two pieces. On this one's got three pieces on it, and for each piece there is a separate domain. And so first of all, we need to recognize, are they going to be asking us for the f function and the g function? So that's depending on the letter that's in front here. Here's an f1, here's a g for this one. So basically 1 through looks like 4 is f, and 5 through 9 is going to use the g function. The second thing we do is look at the number and see where does it fall in these domains. So for number 1, for instance, it says you're going to evaluate f of 0, so x would be 0. This would be your x number that's in these parentheses. So where would that fall? This one says x is less than or equal to 1. This one says that x is greater than 1. So 0 is not greater than 1. It would be in this section, in this domain, x0 is less than or equal to 1. So we need to use this function here. We need to use the 3x minus 1 part to this piecewise function to evaluate this. So you got to recognize where is it going to fall, so which piece of that function do you need to use. And so now 0 can go into here, so you can see 3 times 0 minus 1, and so that's just going to give us 3 times 0 is 0, 0 minus 1 is going to be 1. So this is going to equal a negative 1. So there's our answer for this one. We can say f of 0 equals that negative 1. Let me come down here to G real quick. I'll do a negative 3. I'll do number 6 here. So if we look at G, we know we're going to be using this function here. Where does negative 3 fall in these domains? So negative 3, is it less than or equal to negative 3? Well, yeah, it is. It's equal to negative 3. So it would fall here. It would fall in this first one. It's not going to be between negative 3 and 1. It's not going to be greater than 1. It's going to be less than or equal to negative 3. So definitely we're going to use 3x minus 1 for this one. 3x minus 1. So that's actually the same function as the one up there. And so we're going to plug in 3 times negative 3 for x minus 1. It's going to give us a negative 9 minus 1. And so this is going to give us negative 10. So g of negative 3 is equal to negative 10. There's our answer for that one. Alright, so I'll do a couple more and then I'll let you try some. So we come back up to the f function here. Let's look at number 3. So if I look at 5 for f, where does that fall? So remember, we're going to use the f function on the top one here. This one says x is less than 1, or this one's x is greater than 1. Well, 5 is greater than 1, so we got to use this piece of this function, the 1 minus 2x. And so it's 1 minus 2 times 5 for x, and that's going to give us 10. 1 minus 10 is going to give us a negative 9. So our f of 5 is equal to negative 9. There's our answer. And I'll come down to maybe one more down here. Let me take a look at, let's take a look at number 8 here. So 8 says g is g of 3. So we're looking at the g function. Where does 3 fall? Well, 3 is not less than negative 3. Is 3 in between negative 3 and 1? No. Is 3 greater than 1? Yes. So it's in this part right here where it's going to be the negative 3x function. And so it's going to be negative 3 times 3, which is going to just give me negative 9. So this function is going to equal negative 9 on that one. Now you got to realize if you do get one that's in between, so if we had something like maybe 0 here or 2, or negative 1 or negative 2, then your answer is just this constant number. It is just 2. There's no plugging in. Your answer would just be 2. So go ahead and finish this up. Do 2, 4, 5, 7, and 9. I left you 5 there to try. And then, so pause the video, do those right now, and then play it to check your answers. Okay, so hopefully you've answered these 5 other ones here from 1 through 9. So everything's answered. Just go over the ones here that you did on your own. So at number 2, this one, the function you should be using out of these two for f should be the, oops, hang on. Okay, there it goes. Should be the 3x minus 1, so you're just going to plug in 1, so 3 times 1 is 3, 3 minus 1 will be 2, so you should get 2 for 2. Number 4, the function you should be using for a negative 4, that's going to be also the 3x minus 1, because it's less than, negative 4 is less than 1. And so you're going to say negative 4 times 3, which would give you negative 12. And then negative 12, negative 1 is negative 13 for that one. Number 5, we're looking at the g function now, so out of here we get 0. And you can see 0, you're going to be using the one that's here, where 0 would be in between negative 3 and positive 1. So you're just going to say 2 for that one. It's nothing to evaluate. Your answer is just always going to be 2. Anything in between here is just going to be a 2. And then for g of 1, we're going to use the 3x one, or the negative 3x one down here, because 1 is greater than or equal to 1. And so 1 times 3, negative 3 is just negative 3 for that one. And then g of negative 5, for this one you're going to use the 3x minus 1, because negative 5 is less than negative 3. So negative 5 times negative 3 gives you the negative, or negative 5 times 3 gives you negative 15. Negative 15 minus 1 is a negative 16. Alright, let's move on to the next section. Okay, so our next section is graphing these piecewise functions. We're going to describe the domain and range as well. So we're just going to watch this one. I'm just going to show you this one. There's nothing to write for this one. We'll go on to the extra practice next at the bottom of 129. But for this one, we got to just graph each one of these. So it's negative x minus 4. Your slope is a negative 1. Your y-intercept is negative 4. And where we're going to see that is if x is less than 0. So when x is less than 0, we're going to see that. And so we look at where this one's going to be at. Your y-intercept is here, where x is 0, but we're going to put an open hole right there. So this is not when x is greater than 0. It's not going to be on this side of the graph. It's only on the left side of the graph, the left of 0 for x. And so then at that point, if we start here with an open hole, because it doesn't equal 0, it's just open there, and we use the same slope of negative x, that means we're going to go up 1 and left 1, up 1, left 1 each time, and then we just draw our line that way. And the next one just says x when x is greater than 0, greater than or equal to 0. So this one, the y-intercept is at 0, so it's going to be starting right here. It's also equal to it, so we should be putting a closed hole here on this one. So this one's got the closed hole, and this one's then you have a slope of 1, up 1, right 1, up 1, right 1, and then we draw that. So there's the two pieces of the graph drawn. And then just describing the domain and the range. Domains, where's the graph on the x-axis? So as it comes in here, we see the graph, it's all through here. When we get to 0, it's even at 0 here and continues to go, because this graph here stops at 0, but then it picks up at 0 here and keeps going off and to the right. So that's everywhere, which means all real numbers for domain. So it's all real, domain is all real numbers, and then the range, you can see where is it on the y-axis? Well, it's definitely not below negative 4. It is everywhere above negative 4, though. So this one kind of goes up here. It's going to keep going up that way, and then it picks up here as well, keeps going up on the other direction, but it's just not below here. So it's only greater than negative 4. So that's why y is greater than negative 4. All right, let's try our own here. Starting with number 10, there at the bottom of 129. So number 10 gives us the two functions, negative 4x. So y-intercept is 0. So we could do that, and it's going to be, as you can see here, open or closed is depending on here. So this is a less than or equal to, so that's closed right there at 0. So we're going to have it, I'll do this one right here. So it's going to be closed here at 0. Our slope is negative 4. So this is going to be when it's less than 0. So we're on the left side here. So on this side of the graph only. So I'm going to go this direction from our 0, this closed point. So negative 4x means that we're going downhill for a negative slope. So I could go up 4, 1, 2, 3, 4, and then left 1. That would be a negative 4 slope. Or down 4 and right 1. I just don't want to do anything on this side for this function. So I'm just going to draw an arrow now from there, going up through this point, and draw my arrow like that. Next function is just the constant number 4. So that's where y is 4. So y is 4 is 1, 2, 3, 4. So here's where y is 4 right here. Right, that's 4. And it's going to be not a closed hole, open right there. I'm actually not going to keep the 4. That's a little in the way. So I'm just going to put an open hole here. And then it's a constant straight function going straight across to the right. And that's what that one's doing. So there's our function. Drawn out, graphed. Now we just need to state the domain and range. So domain for this, I'll just put D for domain. So as we come in, this function, even though it doesn't look like it's maybe over here, it eventually will be. That arrow just keeps going off to the left. So the function's everywhere from the left, and it's here as well. So it's at 0, and then it keeps going where it picks up with this function. So it is all real numbers. It's everywhere, both left and right on the x-axis. So we can say all real numbers for that. And then the range, where is it on the y-axis? Well, it's only above 0 here. So it's only greater than or equal to 0, because it does equal 0. So y, we use the y, is greater than or equal to 0. All right, number 11. So our first function is when x is less than 2. So 2 is going to be right here. So here's where 2 is, 2 boxes in. So when it's less than 2, that's going to be on this side then to the left. We're going to see it's got a y-intercept of 4, and it's got negative x, so it's kind of almost backwards. Maybe we might prefer seeing negative x plus 4. So the problem is that this is our y-intercept to graph this. So we might need to definitely use a pencil here so you can erase, because our y-intercept would be 4, which would be like up here. I'm just going to do a little mock point there for now, because we know our graph can't be over here. But then from that point, to get the next point, we would be going down 1 and right 1. So down 1, right 1, down 1, right 1, and so on. Now here's the point right there where it actually really should start. That's the point I need. So I'm actually going to erase that and make that open, because we need to have an open hole right there. So this needs to be an open hole right here when x is 2. Okay? And so I'm also going to erase these as well, because our graph's not going to be on that side of the open hole. It's only going to be on the other side. So actually, no, wait, so it is on the left side. Sorry, it is that way. So it's there, it's there, it's there. So this is where it's going. It's not on this side yet. It's only on the left, so it is here. So I keep these points there. I was misspeaking on that one. So it's going like this. It's going up like that. Not the best drawing. I'm sure you can do better. And then x plus 3 for when it's to the right of this 2. So here's the one where we're probably going to want to maybe erase some things. So x plus 3, this one's a downhill, this one's going to be an uphill slope on this one. So where would it be here? I'm going to use a different color. So positive 3 would be here. That's our y-intercept, and it's up 1, right 1. Go there, up 1, right 1 again, there, up 1, right 1 again here. Actually, I'm going to be probably off my graph. It's going to be a closed hole, so at the 2 here, this is the point right here, and then it's just going to go up from there. So that's a little bit off my graph. That's where it's going. Oh, closed hole there. So this point we don't want to put there, or that one. So that's the function. So it's got the open hole going this way, closed hole going that way from your 2. This is your 2 line right here on x. And now to describe domain and range, domain for this one is going to be all real numbers again, because it does equal 2. It's 2 there. It's everywhere less than 2. It's everywhere greater than 2, and it also equals 2. So yeah, all real numbers again on this one. And for the range, where is it on the y? So it's not below this number right here, which is actually at 2 for the y. So it's actually only just greater than 2. That's where it's greater than, just right there. Alright, so if you need more time, go ahead and pause that and take some more time getting that copied down. Let's move on to our next one, which is number 12. This one's got 3 graphs on this one. So we start with the first one. It's going to be less than negative 2. So our negative 2 is going to be over here. So on this side of negative 2, it's 2x. So it would have a 0 for, this one typically is going to have a, and again, that would be our y-intercept. And it's going to be going uphill. Okay, so if I'm going to be on this side, maybe I'll go this direction. So it's going to go down and to the left. So it could go up 2 and 1 right. So rise over run. So the rise is 2, run is 1. Or it could go down and to the left 1. Same thing, down 2 and to the left 1. And again, it's going to be at 2. So here's the one that's at 2, and it's an open hole at 2 right there. So I need to make that open. So down 2 and right 1, I'm going to have an open hole right there. And I'm going to go down 2 and maybe right 1 more. I'm off my graph a little bit. That's okay, but this is where it's going to be headed. Like that, in that direction. Okay, I can erase these 2 points because I don't need them. On to the next one, it just says 2. So y is 2 between here. So it's y is 2, so where is y2? Y is 2 right here. So between this, so at negative 2, which is closed all the way, so we keep going all the way until we get to positive 2, which is going to be open. We just keep that going all the way until we get to positive 2 right there, it's open. And then past that, it's going to be negative 2x. So again, it's going to be a y-intercept of 0 right here for this one. And it'll be a downhill one. It'll be like going down 2, right 1, down 2, right 1. So it's actually at that point right there. It is a solid hole, closed hole right at this point. Down 2. Again, I'm going to have to kind of eyeball this at right 1, approximately right about there. So this one is closed hole and it's going that direction now. And I'm going to erase these 2 points. We don't need those. So there's our function on the graph. Just each piece, 3 pieces, and just make out the pieces there. And as far as domain and range again, so our domain is everywhere. So it's everywhere all the way until we get to negative 2. It's at negative 2, then it's going along here from all the way to 2, and it's equal to 2 here, picks it up, and it keeps going. So it's everywhere, all real numbers on the x-axis. And then our range, where is the range? Well, this one's a little bit different. So this one's got a couple different ranges. It's definitely below this, which would be 1, 2, 3, 4, negative 4. And it's also, range is at 2. So it's actually at 2 there. So the range would be like, 2 and, or I should say y equals 2, not just 2. I should say range is this, y equals 2. And y is less than or equal to, because we have the closed hole here at the negative 4. So in those 2 places, that's where our range is. Alright, let's move on to our next part. Alright, let's pause here for a joke of the day. Why do bees have sticky hair? Why do bees have sticky hair? Well, because they use a honeycomb. Oh, of course. That makes sense. They use a honeycomb. Okay, so we're at the top of page 130 where we just did number 12. And then number 13 actually is a step function. And so you have a vocabulary word for that. You can go back to finding your vocabulary. Just turn back a page. Over on 128, where it says step function, you have piecewise function, which is given the definition for you on that page. Within step function, you're going to want to write this down. A step function is a piece function defined by a constant value over each part of its domain. So basically, a step function just has all of the functions that are in that, or all the pieces are all constant functions. There's no variables in this, so it's just all constant numbers. And so it's always going to be, should be about over the same domain. Each domain goes about 2 units on this one. And so you can see how that works here. So you have between 0 and 2, you're going to be at 2. And then between 2 and 4, we're going to be at 3. And it just looks like a step. That's why we call it a step function. It looks like a bunch of steps going up. So just each one is a constant little function making the next step and the next step after that. All right, so let's go ahead and try 13. And graph this step function. Okay, so number 13, it's small, only has 3 steps to it, negative 1, 0, and 1. And so we'll see for negative 1, we're going to be less than negative 1. This is actually more about, I guess, a piecewise function than a step function because they're not all steps here, but they are all constants. So it is somewhat of a step function over constants here, but it's not going to look exactly like the step one we just saw. If it had exactly this over the same domain, if they're all going to be going like 1 or 2 units, then it would be a step. So negative 1, we're going to be from negative 1, x is less than negative 1, which is right here. We're going to be at negative 1, which is down here. So it's going to be a closed hole right here, and it's just going to go off this direction, so it does continue to go that direction. We're going to draw an arrow for that. And then between -1 and 2, so from here all the way over to 2, we're going to be at 0, so right here on the x-axis. So it's going to be an open hole here, and it's going to keep going here. I'm just going to make this blue on top here all the way until we get to 2, and then it's a closed hole right there. And then it's got after 2, we're going to be at 1, so 1 is here. So 1 is right here, and it's going to be, actually this is not a closed hole. There's no closed holes on this interval. It should be open. Maybe some of you caught that. It should be an open hole right there. So open there, and then it's closed then at 1, where y is 1, which is here. Closed here, and then it's just going to go off. So it does look somewhat like a step. Like as you're walking here, you step up, and then you step up again, and you keep walking. So that's why it is kind of called a step function, but it works just like a piecewise function. Okay, and then we can do our domain for this one. It is all real numbers, because as we travel in, it is at 2 or at -1 here, then it keeps going along, and it is going to pick it up right here at +2 and keeps going. So yeah, all real numbers. It's everywhere on the x-axis. And then for the range, where is it on the range? Well, it's only in 3 spots here, actually. So it's going to be just y is equal to just these numbers only. So because they're constants, so -1, 0, and 1. -1, 0, and 1. That's our only range. There's no less than or equal to, because there isn't anything in between right here. So because you're stepping up, it's not a continuous thing going along here. It's just only -1, 0, 1. All right, couple last sections here. Just a few more problems. Okay, the next couple of problems ask us to write a piecewise function. So let's just watch this one and see how they do this. So the first thing is, for each piece, the function is linear. So you can see our two linear functions, y equals mx plus b kind of equations. So for the first piece, the left piece, this one here, this is when x is less than 0. So you can see the hole there is on the y-axis, which means x is 0 at that point. And it's less than, it's not equal to. So it's just x is less than 0. That's going to be the domain for this one. And then you just got to figure out, okay, the y-intercept of this, you can see, yeah, is 3. So it's got a y-intercept of 3. And it's going to be having a slope of -1. It goes downhill, or actually no, +1. It's going uphill. It seems like we're going down, but actually left to right, it is going up. So it goes down 1, left 1, -1 over -1. Or you can go here, up 1, right 1, up 1, right 1. So it's a +1, slope +1 in front of x. So that's what our equation is going to be, y is equal to x plus 3. For this next one, you can see right here, it's at 0 again as well. So this one's when x is greater than or equal to 0. That's what it's going to say here. And then it's going to start at this point, which is your y-intercept number, which is -1. And then slope is going to go up 2 and right 1. So it's going to be a slope of 2. So you're going to see 2x minus 1. So x is greater than or equal to 0. That's going to be our domain for this little piece. And then there's your equation, 2x minus 1. And so as we write it, we just write it like this, f of x, because we can give it a function name. So we always want to write these as function names, not just y, because f of x does mean y. And it equals, and they put this little brace here to separate it. You can just do your best to try and draw that. X plus 3 is when if x is less than 0, 2x minus 1 with x is greater than or equal to 0. All right, let's try R2 here on 130, 14, and 15. All right, for 14, so let's talk about the first piece we got going on here. So our first piece, and we can start it, we can just go ahead and start with the answer of f of x is equal to, and it's 2 pieces. We'll put our first piece up here, okay? So this is the piece when it's going to be, I'll just put it down here, x is less than 0 on this piece. Our second piece over here is going to be when x is greater than or equal to 0, because it's equal to 0 there. So that's what we're going to say for the domains. Let's find out what these equations are. So for this one, it is going to be at 0, and it's going to go downhill here. So from here, the next point I can see clearly looks like it's going to be, well, definitely right there. I think it's going to be there, but I think there's going to be another one in the middle, probably right here. So it looks like up 3 and left 2. So it's going to give us a slope here. So from here to here, I think, no, actually I think it's going to have to go all the way up to top. So that's going to be up 7, and then 1, 2, 3, 4, 5. That's it. So rise is 7, and then negative 5. So it's going to be a negative 7. Just put negative in front of this. Fifths. Negative 7 fifths x, and it's at 0 there. So it's going to just be right there. We're going to say comma if x is less than 0. Okay, our other one here is just a constant. It's at 3, so we're just going to put 3 if x is greater than or equal to 0. So there's our function. We wrote it out. So we're just going backwards. And this time they're showing us the function on the graph, and they just want us to write it out in this form here. All right, so this one's got 3 functions going on here. So let's go ahead and put our we'll say g of x for this one. Doesn't matter what you say, what letter you give it. We'll just do it different since we said that was f. We'll say this one's g of x. And again, a nice kind of big thing going on here. First one, we might want to just go for the domain. Which one's that going to be the domain? Probably like this one right here be first. That's going to be the one that's going to be x is here to here. So now there's definitely going to be an interval in between here. So we got x is in between this. Maybe I'll put it up here. So this is going to be x is in between these two numbers, which is going to be 0, and this is what, negative 3. X is in between those. So you always just put your less than symbols. This is less than or equal to, since it's got the closed hole, and that's a less than on that one. And then you got this one. X is in the middle between here of 0 and 1. And again, less than symbol, that's going to be an equal to on that one, and that's an equal to on that one. And then for this one, x again is in between. It's going to start here at 1, and it ends over here on the x at 5, it looks like. And then just less than on this one, and less than or equal to on that one. Okay, so now we just got to write the functions out. These two should be fairly easy to write. They're just numbers. This one's going to be a linear function here. So let's do the first one, which is this one here. That's starting with the negative 3. That is just at 3. So there's 2, there's 3 right here. So we're going to say 3, comma, if, and then we just write this. Negative 3 is less than or equal to x less than 0. Then we come to this one, which is at 4. So we now say 4, comma, if, and then we just write this here. 0 is less than or equal to x and less than or equal to 1. And then the last one, this one's going to be the more complicated one. We need to figure out what the slope is. The slope is, looks like 1, up 1, right 1, up 1, right 1. So my y-intercept would be at 0, because if I go down 1, left 1, y-intercept would be there at 0. So it's just going to be x, just a plain old x, actually. 1 is the slope, there is no y-intercept, so it's just an x, comma, if, and then we write this, negative 1, or it's not, positive 1, is less than x, is less than or equal to 5. Alright, so there's our number 15 written out. Not too bad on this one. I think the hardest part is probably trying to figure out what some of these inequalities are, especially for those intervals. Alright, I'm going to go on to the last problem. Number 16 is next. Alright, so at the bottom of page 130, number 16. So we have a kind of a word problem given to us, and we're going to be writing and graphing a step function here, it says. You can see that's what it says right here in the middle. But let's go ahead and read this. It says a postage service charges $4 for shipping any package weighing up to, but not including 1 pound, and $1 for each additional pound or portion of a pound up to, but not including 5 pounds. Packages 5 pounds or over have different rates. So write and graph a step function that shows the relationship between the number x of pounds and a package weighs, and the total cost y for the postage. Okay, so whenever doing a word problem, if you just read it and you're like, I have no clue, then the best thing to do is read it again, read it slowly, try to understand each sentence and what each piece is talking about. So we're talking, you gotta understand, we're talking about a postage service, and just think about it in terms of, like, if you're gonna go to UPS or just so a mailbox place, and you're gonna go ahead and you have a package you want to ship, and so you're taking a package there, and they're gonna weigh the package. They're gonna put on the scale, see how much it weighs. Well, if it's less than a pound, then you're gonna pay $4. That's what it says here. Anything less than a pound or under is $4. But soon as you exceed that and get to 1 pound exactly, so if it's less than a pound, you pay $4. If it's a pound or any part of 1 pound, 1.5 pounds, 1.7 pounds, you're going to pay an extra $1 for that. And as soon as you get to 2 pounds, then you're going to pay $2 extra. You're going to keep going up $1 for each pound that it keeps weighing. So you're paying just in dollars here. You're not going to pay anything in cents, it says. So that's why it's a step function. And what it says right down here is it gives us what the x is representing, which is the pounds down here. Let's go ahead and just label this axis down here pounds. This is the weight. And then the y is the cost. The cost is going up here, so we can just even put cost. I can't really turn my paper really, but I'll put cost kind of going up there. That's our cost, the amount of money. And so we could say, okay, this is like $2 here. This would be 0 right here in the corner. This would be like $4. We have $3 or $5, $6. $8 would be like up here. This would be 1 pound. We could say 2 pounds is here, 4 pounds is here, and 6 pounds, and so on, to 8 pounds. So go ahead and just label your graph. Now notice you had to also draw these arrows. So I already drew out my arrows. I made it to where it's only the first quadrant, because everything is positive here in this graph. So we don't need a coordinate plane where we see all 4 quadrants. Now the next thing you might want to do is actually write the function out. So we could use f of x, right, as our name for the function. And it's a step function. So we'll use that little squiggly there, little braces. And let's just think about what we got here. So what we'd have here, it's going to be that the amount of money, again, is going to be going up the side here, the $4, the $5, and so on. So you're going to pay $4 right here if, I'll just put if you're between 0, if your x is between 0 and 1. And we're going to put less than symbols there. So a little interval. So you're going to pay $4 if your x is between 0 and 1. You'll pay $5, and you just keep going up. So as soon as you get to 1, as soon as it equals 1, so between 1 and 2, and we're going to put less than and equal to, it's going to equals 1, then it goes up to 5. But not when it equals 2, because when it equals 2, it's going to go up to the next number. And we're going to just keep kind of going on that pattern, and we're going to stop after 5 pounds. Remember this is 1 pound, so here's 1 pound, 2 pounds, and so we keep doing it until we get to a 5 pounder over here for x. So we can say 6, that's going to be if we're between 2, put x here, and 3. So less than or equal to, as soon as we get to 2, it equals 2, but not when it equals 3 yet, because when it equals 3, we're going to the next one. So we pay $7 if we're between 3 and 4. So x is between 3 and 4. It's equal to 3, but not equal to 4. And as soon as it gets to 4, we pay $8 if we're between 4 and 5. And that's where we would stop right there. So it's equal to 4, but not equal to 5, because after 5, as soon as we get to 5 pounds, it says packages 5 pounds or over have different rates. So we're just doing only these numbers right here for the function. So now that we have the function written out, so we wrote the function already, now we just have to graph the function. So graphing it's over here, so we're at 4. So if we're going to put I'll do a red, different color. So we're going to say open hole, and then as soon as we get to 1, which is 1 pound right here, it's going to be an open hole also. So 2 open holes we had here, open and open. But then we're at $5 when we get to 1, so closed hole and then open hole. So there's that step. And then when we get to $6, we go up 1 step here, closed hole, open hole. $7, we just go up 1 up here, closed hole, open hole. And $8 is our last one. Go up 1, closed, and open. And there's the graph. That is exactly what it's talking about here. So you can even see it, the graph. So if you're between, your weight is between 0 and 1, but it's not quite 1 yet, then you're going to pay $4. But as soon as you get to 1, you're between 1 and 2, but not quite 2, you're going to pay 5, and so on. All the way up to where you're paying $8. Anything between $4 and not quite 5 yet, you're pay 8. Okay, that's what that function is talking about. All right, so hopefully you understood the piecewise function and these step functions in this lesson, and now you should be ready to be working on your assignment. All right, so have a great rest of your day. I'll see you on the next chapter.